We're entering an era of the unknown, which is exciting.
Are you scared? AI engineers are moving towards, they found out ways in which they can better reward these models. They're using things called rubrics, R-U-B-R-I-C-S, and verifiers. So rubrics are, so if I were to take O3 or a deep research or DeepSeek, for instance, these models here these are using these kind of methods within reinforcement learning. I mean, when you're kind of sat at your computer and you're able to kind of create the backbone or foundation for a whole system in 10 or so minutes, I mean...
Which would have traditionally taken...
2 days, 3 days.
You're giving away the joy of execution. You're giving away the joy of the craft. Do you think within organisations, agentic solutions will replace executive roles, leadership roles, project managers, any role that is essentially data-driven? There's an opportunity to create a digital, efficient system that can make decisions off that data.
If we get to a stage where these IDEs or what you're using to produce this code are capable of producing massive systems, massive applications, it'll become more of like an advisory role. It's more prompting, proactively producing these solutions that you're leaving it up to the large language model to kind of construct and code them in a certain way. I think we'll always have to have people that overlook.
Baseline. An agentic system that was handling customer complaints, which was a total AI, it was a total digital instantiation, digital voice. But what the program did to do was when the customer gave their complaint, take a sharp intake of breath.
The baseline is designed to create an emotional response.
I've seen things you won't believe.
More human than human.
What is such a small human behaviour that would show shock, or almost a physical reaction to something somebody said? Look, I had this bad experience, and they said that I think over 80% improvement of customer satisfaction of humans dealing with this AI agent just by putting that very small noise. Which is totally synthetic.
It puts people at ease, doesn't it? If you think you're talking to a robot or you think you're talking to something that's artificial, I think the general person would kind of feel a little bit I don't know, I'm not sure how I feel about this. I mean, you often hear people talk about how magic it is and it's going to take over the world. All these jobs are going to go. Things in the news. 300 million jobs are going to succumb to the wrath of AI in the coming decades. But I think, yeah, as I was saying, I mean, it does have being able to code those elements and being able to kind of allow these systems to convey more human-like traits, I think does help.
Paying people to do stuff, you're giving away the joy of execution. You're giving away the joy of the craft. But I like learning filming and audio. You don't, by paying other people to do things, you're losing the opportunity of learning.
I was being opened up to this world of quite fast-paced proof of concept work, and I really enjoyed it. I loved how kind of I had free realm on what kind of technologies I could use. I was learning new things every week, because obviously, as you know, the industry is very fast-paced in itself. And I saw that there were some quite cool things going on in client engineering in a different part of IBM. And I reached out to a few people and I said, look, my job at the moment is moving away from that fast-paced proof of concept work. I really want to kind of maintain that I'm enjoying what I'm doing at the moment. And they said, look, there's an opportunity here as an AI engineer, and I knew that I'd done modules and stuff on AI at university. So I applied about a year and a half ago now. I went through the technical interviews and whatnot, and now I'm here, been an AI engineer within client engineering for a year and 6 months now. Yeah.
What is an AI engineer?
So that's a very big question, because my role, I think you would associate more with an applied AI engineer. So an applied AI engineer is someone that uses large language models to produce applications. And that's kind of what I do within client engineering. We utilize these large language models using, what's next AI predominantly. as the middleware so we can chat to these models. And then we slot those into applications using Python. We produce applications for clients. Whereas other kinds of AI engineers would be kind of heavy machine learning using things like PyTorch, TensorFlow. And while I've got experience and I've used frameworks like that before, my job day to day doesn't really revolve around training models and that kind of thing. It's mainly using those models to produce applications for clients.
Do you think I've heard a lot recently that people are claiming that AI is going to replace coders, developers, engineers? What roles would you be advising or you think are emerging around engineering of AI and LLMs? Is the industry and the market for talent shifting?
I think so. I think we're going to be moving towards more advisory roles as opposed to heavy. I mean, we were talking earlier about vibe coding and using things like Cursor and Windsurf and applications like that to help you and aid you with coding. And I think that I feel like the learning will stem from how do we use these applications as opposed to, how are we going to be using the large language models and kind of the deep intricacies of them. It'll kind of more be to do with, as I say, advisory roles and that kind of thing.
Advising organizations on how to use AI.
Yeah. So I think AI in general is moving from sort of these reactive tools that kind of respond to prompts to a more proactive system that can kind of shape the way we live on their own intuition. So I think, we're already seeing autonomous systems in healthcare, finance, customer service, supply chain. And I think that, I read articles that say, we're going to reach a time where these systems are going to reach almost human-like intelligence or near human-like intelligence.
You've managed to get into a role where you're really supporting the implementation of LLMs into businesses.
Yes.
So you're actually at the front line of the application of AI into organizations. Where are you seeing that really show value at the moment? Like, what are you working on at the moment that you're really excited about, that where you can actually see the innovation having real value?
I think that a lot of it is to do with the speed in which these AI systems can rattle through data. And I was working on a project recently which was quite heavy machine learning, whereby we'd use machine learning algorithms to analyze radio frequencies, and being able to, it would take a human being, hours and hours to rattle through these 15,000 rows in a single table, whereas right now we're looking at minutes with the right kind of computing power to do that, and that wasn't something that was available before to a human being at all.
So data processing with AI sounds like it's just phenomenally quicker.
Yes.
Than whatever we've seen.
Yeah, and also you've got the ability to generate summarizations, text, that kind of thing using the large language models. Is that where
you're seeing current deployments go in and what customers or organizations are using it for?
Yeah, I think a lot of different proof of concept work that we're doing at the moment is we're using large language models to summarize. We're using them for classification, question and answers, so chatbots and that kind of thing. All of these things come together, and it's kind of a massive umbrella of what you can use these large language models for.
So AI engineering roles at the moment are very much around applying generative AI to kind of give access to data.
Yeah. I think, as I said before, my role is predominantly, it's based around producing applications that use these large language models to achieve a certain result for a client. So we'll analyze, we'll look at what their pain points are. We'll look at the user, that has these pain points, and then we'll kind of work out how we can best utilize these large language models in an application to kind of satisfy them.
In terms of those application of large language models, where do you see the development of large language models going? Like, there's very much a perception at the moment where they've reached a certain level of capability and it's kind of flattening out. Like, where else do you enhance that system? Like, where's the data going to come from?
I think I feel as though when you say LLMs are sort of flattening out, I think that they're always going to become better at reasoning, better at adaptability. They're going to be better at multimodal understanding, so not just text, but speech, audio, video, images. And I think as they get better at doing that, they're going to be used and they're going to assume more responsibility within organizations, especially on, the sort of, at the moment, there's a big buzz around agentic solutions and agentic AI. And I think as they get better, agentic solutions are going to become better in and of themselves.
Do you think within organizations, agentic solutions will replace executive roles, leadership roles, project managers? It feels as though any role that is essentially data-driven, there's an opportunity to create a digital, efficient system that can make decisions off that data.
Yeah, 100%. And I think we're talking in a little bit of a distant future here, but I think we'll see swarms of these agentic systems that, coordinating at massive scale, as you say, taking over quite significant infrastructures like city services, for instance, or, massive industrial organizations. They will assume more responsibility in those organizations.
So organization leadership will become a hybrid of machine and human. Essentially, we're looking at cyborg-like organizations.
Yeah. I mean, I suppose, yeah. I think that there may well be physical robots. But I think, we might see
cyborg in terms of a convergence of machines and humans, which we're already seeing.
We're already
there.
It's coming through.
But machines being dedicated in certain roles.
Yes, definitely.
Like a CFO, for example, or somebody who's essentially. There's always going to be a human element, I suppose, but the more and more augmentation with data and algorithms seems to be a good way to go.
Yeah. I suppose it comes back to how you define intelligence, doesn't it, I guess? I mean, intelligence, I suppose, is the ability to reason, to find patterns, but then you've also got this idea of self-awareness and that kind of thing. And I think that's something that is going to be in the far distant future that we can't really comprehend at the moment. Self-awareness, that's something that we'll have to take in. It's multi-sensory. There's so many things that we as humans have and use that make us human beings that I don't think for a long time.
Can that be coded? I heard there was a little video I watched, and it was about an agentic system that was handling customer complaints, and which was a total AI. It was a total digital instantiation, digital voice. But what the program did to do was, when the customer gave their complaint, take a sharp intake of breath. Now, what is such a small human behavior that would almost body language show shock, like or almost a physical reaction to something somebody said. Look, I had this bad experience, and they said that I think over 80% improvement of customer satisfaction of humans dealing with this AI agent just by putting that very small noise, which is totally synthetic.
It puts people at ease, doesn't it? If you think you're talking to a robot, or you think you're talking to something that's artificial, you kind of I think the general person would kind of feel a little bit I don't know, I'm not sure how I feel about this. I mean, you often hear people talk about how magic it is, and it's going to take over the world, all these jobs are going to go, things in the news, 300 million jobs are going to succumb to the wrath of AI in the coming decades. But I think, as I was saying, I mean, it does being able to code those elements and being able to kind of allow these systems to convey more human-like traits, I think does help. As you say, what was it, 80% more better customer
Do you think
success?
there's a moral question on whether we should program machines to behave like humans, or should we know that they're machines? Because there's almost a level of not deception, but by creating an agentic AI, which is a pure synthetic being to interact with customer complaints, and coding in behavioral traits, which actually improves the transaction for the human at the end. I don't know, there's something about it that makes me worry that it's moving towards some sort of dystopia where we can't determine the difference between a real person and a synthetic being.
I think this is where trying to have that safety and control over these agentic systems is very important. And I think agentic AI, I think in the future is going to become far more capable and far more widespread. I think we're already seeing, as I mentioned earlier, these autonomous systems that are capable of handling these multi-step tasks in healthcare, customer service, finance, supply chain. But they are bound by these predefined workflows and boundaries. And I think, as I say, as these LLMs get better, I think we're going to see a lot more of these agentic systems assuming more responsibility in organizations.
How quickly are they getting better?
Agentic systems or large language models?
Agentic systems.
I think lots and lots of different frameworks are coming out recently. I'm not sure if you've heard about IBM BAI is coming out, LangGraph, that kind of thing. All of these.
Take me through each one.
It's similar to IBM Orchestrate in a way, but I think it's a little bit more turnkey. So it's for.
Just give me an idea what these things are.
Okay.
And what's the value of them?
So LangGraph, for instance, so I created an application 7 or 8 months ago, which is partially the reason why I caught you guys' attention, and that was using something called LangGraph, which was it's a building block for creating these agentic solutions. So instead of just throwing a large language model a task, you are kind of describing a workflow and pushing it in the right direction. So it's not kind of got complete free realm. It can't go and kind of access completely external sources or anything like that. You're kind of predefining this workflow so that it's got some structure to it as opposed to none at all. By the same token, I think BAI is similar to LangGraph in that you are constructing these workflows. This similar to a state machine where it's got persistence of memory. There's a router, there's cycles and that kind of thing. But I think that's kind of IBM's answer to it at the moment. I'd say that was kind of where the workflows that I'm familiar with in terms of agentic solutions. That's kind of.
Do your systems see hallucinations? Like, how often are they occurring? How is that manifest itself? How do you mitigate against those unpredictable results?
So it's called supervised fine-tuning, which is where so it starts off as this base model where at the beginning it's just a husk and it's got loads of dials that haven't yet been turned. You insert all of this data from websites. All of those dials are turned, those parameters are changed, those are your weights and your biases. Outspits this base model. And you can think of that as kind of like a website simulator whereby you can query this model. So you could say, I don't know, a spider is an, and it would automatically kind of predict the coming token. So it would say the spider is an arachnid, for instance. And you could kind of copy that text, and you could Control F, Command F in Wikipedia or whatever websites it was using to train itself. Paste that in, and you would be able to see direct correlation between what you're seeing that the model's kind of spitting out and what you're seeing on these websites. That's the base model. Has no kind of conversational elements, not ChatGPT yet. Next level is where we come to that supervised fine-tuning, where we're then in a similar fashion to the pre-training. We are training this model on how to talk to a human being. So we load lots of data in. We get human beings to create human and AI conversations, and we train in a similar fashion to before the model on how we want to navigate those human conversations. from there, we are seeing there are these specialized tokens. So when you're communicating with these models, there are specialized tokens that it begins with. And when you're communicating on ChatGPT, you are seeing your input text will be replaced with these special tokens on the side and be able to let the model know when that it's a user query and when the AI should respond. And in terms of hallucinations, the way in which these models are kind of mitigated against is when you are human beings you're pointing them in the direction of tools and that kind of thing to stop these hallucinations from happening. I mean, classically, you've seen that models can't really perform calculations very well. That's to do with the fact that these tokens are coming in one stream, gets a little bit confused. So you'll see, if you just ask a model to calculate something off the back with no tool use at all, more often than not, it's not the best at doing that. Whereas if you're kind of letting it lean on tools, these tools are then helping and aiding in order to complete a task. By the same token, if you were wanting to search something, I mean, a lot of these models are kind of trained up to a certain year, 2023, 2022. They'll probably hallucinate because they don't have that level of knowledge yet. And when you ask it, and when you give it the capability to lean on a tool, you're essentially removing that hallucination.
When you say tool, like, could web search be a tool?
Yes.
Because obviously ChatGPT, which seems to be just the freight train in all of this, setting a standard expectation around ease of use, human-like interaction, empathy, synthetic empathy.
Yeah.
But yes, it's only been trained to a certain date, but it will do a real-time web search and data retrieval.
Go straight into the context window, and then that'll be used to generate text, basically. And the context window is essentially what the large language model uses as a base to form the rest of the tokens.
So if web search is a tool, what other tools can language models call on to augment its response?
Okay, so I think a good example of this would be an application that I made with my workmates about 6 or so months ago, and it was actually it was for use inside a banking use case. So we gave users the ability to talk to their transaction data, and one of my colleagues lovingly gave us his bank account details. Essentially, it was an API key we used
like
for his
statements.
No. So it was an API key for, I think it was Starling Bank,
like the open banking.
Yeah. So we basically had access to his complete transaction data for one of his accounts.
So you could say, what's my most expensive purchase? Where have I spent most money?
Exactly. So you could query this system and you could say, I'm spending too much money. I've spent too much money in October. What it would do then is, so you've got a series of different agents here. And just to clarify, when I say agents, these are kind of smaller cogs in a bigger wheel. I think when we talk about agentic systems, these are systems that incorporate lots of different agents, multi-agent systems that kind of work in concert to achieve a task. So for instance, with that application I was just referring to, at the top level we had something called an orchestrator agent, which was, you could think of like a project manager basically. So it would look at a task, it would know the tools it had at its disposal, and it would plan accordingly, and it would kind of oversee the task. Then you'd have other agents in that flow. So you'd have, we had a Python agent, which would generate code and produce graphs. We had a SQL agent, which would kind of grab the numbers and the transactional data, so all of the prices and that kind of thing, all of the different transactions that my colleague had made. And also we had a search agent as well, which the large language model could lean on, which was web search. So you could, find things that were a little bit less expensive to what you'd been buying, and such things like that. And then when you put all those together, I think that's what kind of forms that agentic system, is when all these agents work in harmony to complete a task.
So any specific response is like the aggregation of 4 or 5 different agentic engagements that are then giving you a response in real time and managing it into a single conversation.
Yes.
Which is very powerful.
It is very powerful. It is very, very powerful. But obviously at the moment there are limitations. As I said, at the moment we're working it's quite constrained. And as I mentioned before, LangGraph and such things like this, we are constraining these agentic systems to defined workflows by developers and AI engineers. And I think we'll see, as these large language models do become better at reasoning, adaptability, and multimodal understanding, we'll see them kind of navigating away from those strict boundaries and moving towards more kind of open and being able to kind of grab things from external sources as opposed to things that are predefined by an AI engineer.
I just want to come back to this AI engineer point.
Yes.
I was just reading, the demand for these type of roles is growing 100% every year. I think LinkedIn specifically are calling 75% year-over-year growth. So this AI engineering is seen as an emerging role. So can you try and explain to me, you're building agentic systems, you're architecting agentic systems, you're working out where all the different sources come from to populate the context window to create valuable, entertaining, educational, insightful, whatever responses. What's the route to AI engineering, and where do you see this role going over the next three years?
Where's the route? So if somebody wanted to start out as an AI engineer?
So is it people doing traditional computer science, or is this more? In some ways, there are creative elements to AI engineering.
Definitely.
Around language and maybe creative industries.
Definitely.
Is not computer science as such.
No, I mean, look at prompt engineering roles now. I mean, those have kind of popped out of the woodwork recently, haven't they? Where you kind of, I suppose an English degree would help you out with things like that, being able to kind of steer these large language models to certain outputs in a way that is very efficient, very fast, and also gets the most out of these models as well. I think in terms of where it's going, there's a heavy... So AI engineering is going more towards... In recent weeks and months, there's been a heavy emphasis on reinforcement learning, especially within agentic systems. So after, as I mentioned before, after that supervised fine-tuning step in a large language model, moves down to reinforcement learning. And you can think of that as you're rewarding large language models for behaving in a certain way or doing certain things. So classically, at the beginning of reinforcement learning, would either be you'd give a thumbs up or you'd give a thumbs down.
Yes, which ChatGPT still has.
Yeah, it does to a certain extent. And these are kind of the more elementary models. These would use reinforcement learning that was solely, yes, no. Whereas now, AI engineers are moving towards, they found out ways in which they can better reward these models. And I was reading something the other day. I think it was on another guy did a talk, and he was saying that they're using things called rubrics, rubrics, and verifiers. So rubrics are if I were to take O3 or a deep research or DeepSeek, for instance, these models here are using these kind of methods within reinforcement learning. So rubrics are these checklists that you provide that kind of give criteria on how well, if I'm using the agentic system, so the LLM that's kind of providing the reasoning against these agentic models, that checklist will be criteria on, okay, it's done this right, it's gone down this particular path. It's, say for a customer service agentic solution, it's been empathetic. That's one checklist. It's used this number of tools in this way. It's now being able to navigate through this issue in this certain way. And those rubrics are these kind of more enhanced, kind of granular checklists that these verifiers are then looking against to reinforce those models to become better at what they're doing. So I think AI engineering there's going to be a heavy emphasis on reinforcement learning and using these rubrics, using these verifiers to be able to produce better, more efficient, better reasoning, adaptability. These models are going to become better and better and better at doing this, especially in an agentic setting.
On this point about the assessment of success of the LLM.
Yes.
I want to ask the question, what's more important, what should be more rewarded? accuracy or user enjoyment slash how they feel? Because say, for example, I'd made a decision to buy, a new device, and I've made the transaction, and if I then go into an LLM and say, have I made the right decision? And it goes down to the processor and the cost and the storage capacity, and it actually thinks maybe you haven't. The user may not want to use that AI again because it's told them something they're not happy with. It hasn't validated a decision. Whereas if the LLM opts to support and be empathetic in a way that you've already made the transaction, I'm now going to be more emotionally supportive and demonstrate more EQ over IQ. And the user comes away thinking, actually, yeah, I have bought the right device. It might not have the best processor, but it's fit to my needs in more softer, subjective elements. So LLM guidance on objective versus subjective, intellect versus emotion, could redefine the way we want to interact with the system. So you may choose to reward an LLM on emotional interaction, i.e., does the user keep engaged? Are they engaged? As opposed to you just give them the data and they don't engage.
So this is where different kind of rubrics will come in, so different checklists. So it depends on the industry. For instance, if you wanted something a little bit more conversational and puts users at ease and a kind of more
in frontline workers, in mental health applications,
yeah, exactly.
There are softer things that may involve, that goes beyond hard numbers.
Definitely. And I think that'll just be a different way of approaching the validation and looking at, they'll construct different types of these checklists that they'll kind of compare the results against. And they'll look at different elements of it. So as you say, it was very empathetic, yes or no. If it wasn't, it would kind of steer the large language model to be more empathetic next time because it's kind of been deducted a few points. Or, if in the mental health area, you've kind of, you've been able to put the user at ease in some way because you've used softer language. Those kind of things will be taken into account in these rubrics or checklists that they're kind of using the verifiers to validate the LLMs against.
All this has been predicted in science fiction, Sam.
I know.
Like, all of this has already happened in movies. The way that Hal spoke in a very gentle voice, I can't open the pod bay door, Dave, but in a very calm, relaxing, do you think we're seeing science fiction play out in reality?
Yeah, I think it's going to be a lot more constrained than it's made out in films. I think, the classic thing is, AI is evil. It's going to take over. We're going to see this
Why
massive
do people
dystopia.
feel that? A lot of people react quite negatively to content on YouTube and others that is pro-AI. They feel as though they use words like, this is AI propaganda. This is dangerous. And these are intelligent people who are genuinely frightened or intimidated by us allowing machines to take control.
I think it's the next step for us as human beings, though, isn't it? We were intelligent enough to be able to create these machines. I think the next step is being able to manage them safely. And I think, obviously, we're emotional beings, aren't we? This is very new. There's always an uncertainty on things that people don't 100% understand yet. Creating these fail-safes and making sure that we are structuring these workflows in a certain way, I think we'll mitigate against things that can go catastrophically wrong.
On that, when you're implementing agentic systems,
yeah,
is there emergency switch-off buttons? Are there ways to undo things that, like if something starts behaving erroneously or in an unpredictable manner, what's the fail-safe?
So you've got so we incorporate sort of a max retries on things. So one of the classic kind of tendencies for an agentic system is that it loops round until something's complete. And you can specify how many times it will do that before it kind of gives up altogether. So I suppose you could view that as some sort of fail-safe there. In terms of kind of navigating in a certain way, providing the large language model with better descriptions of the tools that it has at its disposal. And I think one of the things at the moment as well that's an issue is you can oversaturate agentic systems with lots and lots of tools. I think I read something a few months ago now that the maximum number of tools that an agentic system can kind of handle at one time is around 7. And obviously there are ways to mitigate that, so you can kind of store the descriptions of these models inside a vector database and have the large language model kind of, well, you query the vector database on a given user's query, and it would return just the pertinent tools that it would use. It wouldn't kind of go through every single tool that it had in a list. So you kind of vectorize the query and be able to find the tools that are kind of relevant to that particular query, which kind of mitigates that whole only 7. But as I say, there are limitations to these large language models whereby you can oversaturate, and the results start to become a little bit, I suppose, not as credible. It kind of becomes a little bit confused, and it's not as useful. Yeah.
So it's about rolling it back sometimes. What about the cost? I mean, I've spoke to a number of people who are frightened of engaging these systems just because of the amount of resources, compute, storage, network, inferencing costs on their GPUs. There's an acute awareness of the value of NVIDIA, trillions of dollars. Yeah. There's a lot of money moving around here. So, what's the reality of switching on these agentic systems? Is cost something that needs to be? Is it intimidatingly expensive, or is there a cost saving? What's the reality?
I think, it's all to do with tokens, isn't it? With agentic systems and large language models, the more tokens you use, the more money you're going to spend.
So how do you know how many tokens you're going to use?
So you'd use, for work, I use obviously what's next AI, which kind of gives you an insight into how many tokens you've used, and obviously off the back of that gives you a cost per token and allows you to gain an insight into other metrics as well. I think depending on the industry, depending on how often it's being used, depending on the data that it's pulling, compute power, it all adds up, doesn't it? But for small proof of concepts that I'm kind of dealing with, it's not massive amounts of money. But as I say, for big corporations, or in the future for city services, be controlling traffic lights and putting up, it would understand when there are roadblocks and things like that. That's going to take some serious compute power. But in the future, there'll be, more efficient ways of using and training these large language models, and thus, the tokens that are being used will be less expensive.
Which brings us to the quantum, really. IBM themselves, and I guess we're here at IBM today because there are very few companies on the planet who are able to stand up complex, classically physics challenging technology. Obviously Microsoft, Google, IBM. I know there's a set of kind of ecosystem players in quantum, but there's a roadmap suggesting an AI quantum machines and applications are going to be optimizing drug development, medical research in the next 5 years. If compute, in your systems where computations are limited to the agentic AI, giving them unlimited compute through parallelization and quantum, what does that even mean?
So all of these, orchestrating really complex tasks is going to become something that's, when processes with something like this, millions and millions of more processes can be done per second than the classic computers that we're working with at the moment. And I think in terms of agentic systems, if you incorporate a massive system like this into the mix, we're going to see, as I say, the orchestration of some seriously complex workflows emerge.
So do you believe there are answers in the data that exists in the businesses and the organizations in the world that we haven't accessed because we haven't managed to put AI, highly powered AI systems to summarize and analyze?
Find patterns.
Does the answer exist within the data we have? Or is the universe got a level of randomness that where we couldn't possibly predict the future by looking at our existing data?
I think that these computers will hopefully be able to unlock patterns and find things and be able to create formulas and things that we're never able to perceive or understand from. What we've got is the data we've currently got. haven't we? I think, as you say, finding those patterns and unlocking, formulas and things like that will be far, far easier. And at the minute, it's all about time, isn't it? Millions of processes for one human being. It's going to take a lot of time. And I mean, over the past 60 years, we've unlocked lots of different formulas and data and we've learned a lot of things about space and the world and the universe. And I think if we're able to leave one of these things on for a while, and we're able to analyze and find patterns with these kind of processes going on millions and millions and millions of times faster per second than what was ever able to happen before, I think hopefully we'll unlock some magic going forward.
It's very exciting, I think.
It is. I think it's
very
really
exciting.
Yeah.
I feel as though we're entering an era of the unknown, which is exciting.
Are you scared?
In some ways. I think I'm at an age now where I don't really get scared, but I can see the scope is quite intimidating. Because remember, I've been working on classical computing since the late 90s, where you've always been constrained by network, storage, or compute.
Yeah.
You've moved the bottleneck between the three. You've improved computational power. The storage starts to become a limit. Processor goes into wait I/O. You're waiting for access. We've massively improved that with in-memory, extremely fast storage. There's all sorts of things as we've moved that forward. But to think that we could potentially move to an infinite parallel state of compute, it's intimidatingly large, the scope in which we could point that system at. And I think that for me, I've always had a perception of the superiority of the human brain over silicon and computing. Whereas I have to think to myself, in the next 50 years, are we obviously and quite apparently going to get to a point where silicon computation, or whatever sits in that thing at the bottom of there, exceeds biological intelligence?
Yeah.
And if that happens, that I am scared, I think, of that.
Yeah.
Because then we move to realizing that we're intellectually inferior to a system.
Yeah.
Which is I think a marked shift.
But I think that's where the whole safety constraints and things are going to be put in place, those fail-safes.
Well, we think we can put fail-safes on it, but if it's dramatically more intelligent than we are as a human race, how could we possibly hope to control it?
They'll probably end up finding their own language and they'll be able to communicate. We won't understand what they're saying to one another, but they will have constructed a far easier and better way than us humans were able to. We've created English, haven't we? Mm. They'll be so intelligent that they'll kind of create their own languages and we won't really understand what they're kind of talking about. And when you think of things like that, it gets a little bit kind of eerie, doesn't it?
Bring it back to the reality of language, though, because I think you in your daily role, mm-hmm. you're using all sorts of tools.
Yep.
Kubernetes, Docker, I assume, traditional, container management, container of coding. You be using the public cloud coding, but we're seeing this emergence of vibe coding. Yes. And conversational coding using tools like GitHub, Copilot, and obviously Cursor. Just as a expert craftsman at the front of AI engineering, what are you using to make your job higher quality, more efficient, faster?
So the more menial, Cursor is one of them. Windsurf is another. That conversational way of working is, you can complete some, scripts and things like that and applications in, 50% faster than you ever could before, which is, it's a lot. When you kind of sat at your computer and you're able to kind of create the backbone or foundation for a whole system in 10 or so minutes,
which would have traditionally taken,
2 days, 3 days.
So it's not 50%. You're going from 2 days to 10
minutes.
Well,
yeah. In a whole, when there are groups of developers all using this kind of vibe coding. It really does mitigate the amount of time that it takes to produce applications, and all by just kind of conversing with these large language models that are able to kind of output. So that your code will be in the context window of these large language models, and it will be able to construct. It's like predictive text, so it's code predictions. So you'll see it appear, oh, did you mean this? And more often than not, you've got a little smile on your face and you think, yeah, I did mean that actually.
Interesting.
press tab, completes it for you. And if you've got you want to debug, you kind of open up a chat window. You can say, oh, I've just received this error in the terminal. Can you kind of go through the code and look at it for me and try and work out where the issue lies?
And does it find the issue?
Yeah, I mean, a lot of the time it does. I think there's still a way to go. I think there's definitely promise. I think it's still early. But I think, day to day for the average developer, I think it does really, really speed things up. But I think by that same token, I think we're going to be losing. I think people are going to become more and more lazy with developing. I think that's going to be an issue. I think that, if you're able to walk into an interview, a technical interview, and you can just have Cursor kind of produce the response for you. That's going to kind of be lost on the next generation, isn't it? That knowledge of code and how it works will kind of be lost, won't it? Because it will be kind of.
But what is so with a fully augmented engineer with Cursor? What's the human left to do? Because for my simple mind, you could argue a farmer is cheating by using a great big tractor, right?
Yeah.
Because he isn't hand hoeing the field. But there's no way we could produce enough food and cultivate thousands of acres with hand hoes and horses, right? So we cheat, quote unquote cheat, by bringing in mechanization, automation. That's like we've been through the Industrial Revolution. That's kind of what it is. But the farmer is still left to look at the weather, drive the tractors. We're maybe even moving post that now. This conversation may date quite badly, but what is the end? What are developers left to do in a world where you have code building assistance? You still need to know what you want to create.
It'll be back to that reinforcement learning element of it. We'll be kind of advising. We'll be advising these systems on the best ways of working on these workflows. How best we can approach these problems. Understanding the problem, I think, being able to really, at a granular level, understand what is required and what you need for the large language model or for Cursor to produce for you. I think that if we get to a stage where these IDEs or what you're using to produce this code are capable of producing massive systems, massive applications, I think it'll become more of like an advisory role. So you're kind of just more prompting than, as I said earlier, it's kind of proactively producing these solutions that you're kind of, you understand how they're going to work, but you're leaving it up to the large language model to kind of construct and code them in a certain way. And I think that's where we as developers are probably going to go in the future. We'll kind of be looking after. I think we'll always have to have people that overlook and make sure we're on the right tracks. Because I suppose with the more data and the more understanding that these large language models have on code, we're always going to have people that can write code. Because otherwise, how is it going to learn the new frameworks? How is it going to understand if a new programming language comes out? How is it going to understand?
Is it not able to write its own programming language?
It's a very good question. In the future, I would assume it probably will be. It comes back to the whole.
We talked about AIs creating new languages.
It's probably going to create new languages to talk to one another, but I think.
Will we get to a point where these artificial intelligence language models will be able to generate new coding constructs, languages?
And teach us about those coding constructs.
Maybe it won't need to, or just complete what we require.
I think that's definitely within the realm of possibility, for sure, in the coming decades, definitely.
Decades? So you think...
It's so fast-paced, it's almost impossible to say.
I've found that even just trying to keep up with the news sounds difficult. So I've actually stopped trying to hack, to trying to work out what's happening every week, because I'm trying to work out whether everybody just wants to be an AI expert, so they're speaking about it in the media, or it's actually moving that fast.
Yeah. I was reading in 2075, we're going to have, physical robots and swarms of these AI agents.
I think it'd be much earlier than that.
I think it will be as well. I think it will be.
I think they're underestimating 5 years.
5 years?
Yeah.
I suppose Tesla's already rolling out these robots, and I mean we've got Boston Dynamics as well, but these smaller.
The
kind of robots.
Boston Dynamics human robot that I've seen the video of is undetectable. It doesn't look like it looks like a human actually moving. Do you know, and I know physiotherapists that have watched a recent one of this Boston Dynamics humanoid robot crawling, and they're saying the way the limbs, the hip joints are moving, it looks human in its way.
Yeah, I think
it's surreal when I see this stuff.
And I think if you incorporate a plethora of sensors all over this robot, and you throw in a sort of an agentic way of working, an agentic workflow, I think if it has the ability to navigate the world as we do and understand and be able to kind of access tools, and I mean, who knows? I mean, would self-awareness in the future, will it ever reach that stage? I'm not sure, but it's obviously something to think about.
Just to finalise on this extreme programming, this agile programming, what are the big shifts in the next 3 years? Where are you going to find more efficiencies, more improvements in quality? Like, are Cursor releasing new versions every month? Like, where is this going?
It's a very good question. It's a big question. I think Cursor are going to incorporate more access to more tools, and I think that at the moment a large language model can only do so much with code. I think as the large language models become better with multimodal understanding, for instance, we can talk to it instead of just typing it out. We can give it an image of a framework or a graph of like a data flow chart, and it will be able to construct massive amounts of code for these applications. I think it's going to get better and better at doing that. I think it's just a matter of time, really.
Listen, we've discussed some. You're at the front end of AI engineering. You're part of an emerging role, so it's very exciting to be able to speak to you. And also, you're at the start of a fantastic journey that seems to be happening so quickly. And to be a pioneer and early in that space means the work you're doing is hugely valuable to the organizations that you work with and vendors and everybody. We've touched a few times on this idea of sentience in AI and language models moving beyond just inferencing based on past data, but actually maybe starting to create new ways of communication, create new things. And if indeed they turn to sentient creation, in some ways that's quite an intimidating idea for us to consider. You're using tools on a daily basis to optimize your own role. Sam, do you believe that AI will take us to a utopia or a dystopia?
I think if we incorporate the right controls and the right fail-safes, I think utopia is definitely something that we could reach. I think if we get it right, a lot of the drudgery of everyday life is going to be reduced. I think that we're going to see a much more fast-paced lifestyle. I think that, as I say, all the menial tasks will kind of be reduced, and we'll be left to more sort of human pursuits or strategic, creative ways of working, and kind of not really reduced down to just, as I say, the menial tasks.